Welcome to the review for the Unit 3 test in Algebra 1, Introduction to Functions. Let's get right into it. So the first problem said express the relation as a table, a graph, and a mapping. Then determine the domain and the range. So the first thing we're going to do is we're just going to write down the points here. The problem is that that's the thing that everyone wants to do first. But that's not really correct, because when we put things into a table, we expect them to be in order from least to greatest. So really our table should look like this. As it should be -3, 2, -2, 5, right? We're going to put them in descending order, or increasing order, sorry, for the x values, for the domain. And then 1, 4, 2, -1, and then 3, 4. And this will actually make it much easier to graph now, because now we'll just go and we'll go -3, 2. And here, let's do a different color so it's easier to see. -2, 5. One, 4, 2, -1, 3, 4. And then for our mapping, we'll go -3, -2, 1, 2, 3. But then we're going to need to put our y values in order from least to greatest. So that would be -1, 2, 4, 5. And so the -3 maps onto 2. -2 maps onto 5. 1 maps onto 4. 2 maps onto -1. And 3 maps onto 4. And then our domain here is, since there's just values, we would just list the x values as the domain. And we would list the y values as the range. Express the relation shown in each table, mapping, or graph as a set of ordered pairs. So we're going to do a set, we need a bracket. And then we would list the ordered pairs. -3, 5. -2, -1. 1, 0, 2, 4. So there's our set of ordered pairs. All right, let's try it again. So we go 1, -1, then 1, 3, because look at this, 1 goes with -1, then 1 goes with 3. Incidentally, that would mean that this relation is not a function, because for that x there are 2 y's. Then we'd have 2, 2, and 3, 2. And we would use the brackets to close the set. All right, now this one, so we're going to once again list our ordered pairs. So the first ordered pair is -3, -1, and then -2, -2, then -1, -3, then 1, 1, 2, 1, and 3, 1. Remember, when we write an ordered pair, it's always the x value, comma, the y value. Right, so find the domain and range. Here, there is discrete domain and range, meaning there are only points. There's no lines between the points, so these are the discrete values in the function. And so the domain here is going to be the x values. -3, -2, -1, 1, 2, 3. Oops, sorry, that's an awful 3. 3. The range is going to be the y values. Now, we're going to go from bottom to top this time because we want to put them in order. And so that'll be -3, -2, -1, 1. Now, for this one, these are not discrete points. This is continuous. And so there are an infinite number of points between here and wherever we're going. So we can't list them all. So instead, we're going to have to list this in one of two ways. We can either use set builder notation and say the domain is all values of x such that x is, now, what is the highest x value is 4. And then the x values keep going this way forever. So we would say our domain is all values of x such that x is less than or equal to 4. And that's what's known as set builder notation. You could also write it in what's known as interval notation. And you would write the lower limit, which is -infinity, and we'd go up to the upper limit, which is 4. The square bracket here means that this endpoint is included. You will notice that we have the same, that goes along with the less than or equal to. Now the range is all real numbers. In plain words, it goes up forever and it goes down forever, because this line keeps going up and up and up, and this line keeps going down and down and down. So every number that we know of in the real number set is going to be included in the range. In interval notation, that's pretty easy. That's -infinity to infinity. We're going from the smallest number we can imagine to the largest number we can imagine. In set builder notation, you may not have seen this, is what we would write is we'd write all values of x such that, and then we're going to use some notation that you may not have been taught in class, and if not, that's okay, because we would accept this part right here, all real numbers, is x is a member of the set of real numbers. All right, for this one, once again, the domain is continuous. We need every point between here and here. So how do we define that? Well, we would say all values of x such that x is greater than or equal to 1, 2, 3, 4, -5, but less than or equal to 1. Or we could use interval notation and just say that the domain is the interval from -5 to 1. The range is going to be all values of y. Hold on, I'm sorry, I messed up here. I just realized. Sorry, go back. That should be y. Always remember, domain is x values, range is y values. I apologize. Y such that y is between -3 and 3, or the interval from -3 to 3. We use square brackets because the endpoints are included. All right, find the range of each function for the given domain. And so they give us a domain here. They're telling us what x values to use. So we're just going to plug in those x values and see what y values we get. Oh, sorry, I'm going to pause for a second here to answer the phone. And we're back. Sorry for the interruption. So all I'm going to do is it's asking me, hey, what does y equal when I plug in -3 for x? The answer there would be -11. So my first, and then it's asking me, okay, how about when you plug in 0 for x? And I would say, okay, y equals -2. And how about when you plug in 2 for x? And I would say, okay, y equals 4. So my range would be -11, -2, 4. Let's keep right on rolling here. So find the range. Once again, same instructions. They're giving us a specific domain, so all we need to do is plug those numbers in to find the range. So we would go y equals -2 times -3 plus 3, and that would be 8. We would do y equals -2 times 0 plus 3, which would be 3. And then we would do y equals -2 times 2 plus 3, which would be -1. And so our range is -1, 3, 8. Remember that when you put numbers in a set, we always go from least to greatest. All right, make a table to represent each function, then use the table to graph the function. So we're just going to pick some points. I'll go -2, 0, and 1. And so when I plug -2 into this function, when I plug -2 in for x, I get out -2. When I plug in 0, I get 4. When I plug in 1, I get 5. So what I will do is I then plot those points. -2, 2. Oops, sorry, no, I messed that up. So that's not -2. That's +2. So that means this point is there. 0, 4, 1, 5. And what we see is a linear pattern. If we plugged in more points, we would get the points here. And you might get these points when you plug in yours, because you get to pick what x values you plug in. You just want to make sure that you plug in x values that are on the graph. And then, because we're not dealing with specific elements of the domain, we would connect the points in the pattern to represent all the points in between that we didn't plot. Y equals -x. So we'll just go -2, 0, 3. Once again, you can pick whatever x values you want as long as they're on the graph. However, if you pick an x value and the y value is not on the graph, then you should pick then try some different x value for now. And so this would be 2, 0, -3. And so when we plot those points, we get what we would see is if we plotted the intermediate points. And there's our graph. Make sure you always put your arrows on the end to make so that people know that that function continues on to infinity, or negative infinity as the case may be. All right, let's see here. For this one, let's go -2, 0, 1. So when I plug in -2, I'll get -5, -1, 1. So -2, 5, 0, -1, and 1, 1. And if we were to plot intermediate points, we would get that, and so we connect the line, and there's our graph. All right, once again, now, here's where it helps to think about the numbers you're picking out. I can plug any numbers I want into this equation, but the first thing I'm going to do is multiply it by 1/2. So the numbers I plug in are going to work out a little bit nicer if I plug in even numbers. So 1/2, and I'll show you, 1/2 times 4 plus 1 would be, I'm sorry, negative 4 would be negative 1. 1/2 times 0 plus 1 is 1, and 1/2 times 2 plus 1 is 2. So if I plot my points here, I get negative 4, negative 1, 0, 1, and 2, 2. If I were to plot intermediate points, or pick some different points, I'd end up with those, and I end up with a function that looks like that. All right, for 18, 19, 20, and 21, this is easy. We're just using function notation. And so it's very similar to what we were just doing in the table. Is what they're asking us to do is to plug 4 in for x into the f function. So f of 4 is going to equal 3 times 4 minus 1, which is 11. So we would say f of 4 equals 11. Over here, we're saying plug 2 in for x, but the g means I'm plugging it into the g function. So g of 2 equals 2 squared plus 2. So g of 2 equals 6. Once again, for number 20, I'll be plugging negative 5 into the f function. And this will give me negative 6. So we would say f of negative 5, equals negative 16. For number 21, we do g of negative 3 equals. Now, a word of caution, and I broke my own rule, is when you plug in functions, especially if you're going to be plugging them in the calculator, when you plug in a value for a variable, you always want to put it in parentheses, because that way the calculator doesn't make a mistake. And so we would say g of negative 3 is 6. All right, determine if the relation is a function. A relation is a function if for every x there is only one y. And so when we look at a graph, the easiest way to determine that is to do what's known as the vertical line test. If we draw a vertical line and then we run it through the function, if we ever intersect more than one point, we got a problem. Well, on number 22, you will see here, we got a problem. So this is not a function. And we see the same problem on number 25. Oops, sorry. Is on my vertical line, I once again am intersecting the function more than once. And so once again, this is not a function. Here, this confuses a lot of people, but remember, for every x, there's only one y. So when I plug in 5, I get one answer. When I plug in 2, I get one answer. When I plug in 0, I get one answer. And when I plug in negative 3, I get one answer. So this is a function. On the other hand, here on number 24, when I plug in 4, I get 2 and 5. So for that x, there are two y's. So this is not a function. Then for 26 here, once again, we're looking. When we plug in 2, we get 5. When we plug in 4, we get negative 2, 3, 5, negative 2. None of the x's are giving us more than one y, so this is a function. Where on the other hand, here on this number 27, here when I plug in 6, I get negative 1. But here when I plug in 6, I get 5. So for this x value, there are two y values. So this is not a function. All right, a puppy is born weighing 16 ounces, and every day for the first 2 weeks, the puppy gains 2 ounces. This situation can be modeled by the equation y equals 2x plus 16. But what is a reasonable domain? So now we're asking us to think about what numbers can we plug in that make sense. And so X is the weeks the puppy's alive, and Y is the puppy's weight in ounces. So the domain is, we can go, a reasonable domain is, it has to be greater than or equal to 0. Your pet can't be negative weight. And our range has to be greater than or equal to 16 ounces. Yeah, maybe we can go a little bit lower than that. Well, the puppy's gaining weight 2 ounces for the first 2 weeks. So the other thing is, it says this model only goes on for the first 2 weeks. So that means sorry, X is in days. Sorry, I messed that up. It's that it only goes on for the first 2 weeks. So our reasonable domain is X has to be greater than 0, but it also has to be less than 14, because this only stands true for the first 2 weeks. So let's go 0 days, 1 day. Let's go 2, 4, 6, 8, 10, 12. There we go. We know that this was 16. And then we can plug 2 into the equation, we'll get 20. Plug 4 into the equation, we'll get 24, 28, 32, 36, and 40. And then we need to label this. So this is going to be days, and this is going to be ounces, dog weight. And then we need to make sure that we use enough. So let's go 2, 4, 6, 8. See, that's not enough, is it? So instead, sometimes you got to try this. We'll go 2, 4, 6, 8, 10, 12. And for ounces, we'll go 2, 4, 6, 8, 10. Oh, that's not going to work, because this top number has to be 40, doesn't it? So sometimes you got to play with these things, guys. So let's go 2, 4. We'll do it this way. So I don't have to write so much. 4, 8. I don't even know if that's going to be enough. We'll see. 12, 16, 20, 24. Nope, I'm going to run out of room on that one. So now, I'm going to try something different. We'll go 5 every 2. So 5, 10, 15, 20, 25, 30, 35, 40. There we go. And then we would plot our points. 0, 16 is going to be about there. 220 is there. 424 is about there. 628. 832. 1036. 1240. And there is our function. Sorry, if I had plotted those perfectly, they'd form a straight line of the puppy's weight. Last problem. A tree is planted that is 2.5 feet high, and every year it grows half a foot. The species of tree only lives for 10 years. The situation can be modeled by y equals 1/2 x plus 2. So what is a reasonable domain? So once again, x is years, y is feet. So the tree only lives for 10 years, so the domain should be between 0 and 10. Now the range is a little bit trickier. What we would do is I would plug in 10 here. So I'd go 0 2, 4, 6, 8. We'll do a 9 and then a 10. And we know that it's 2 feet tall. Now if I plug in 10, we would get a height of 7 feet. And so our range should be values of y. Let me just check something. Between 2 feet and we would say 7 feet, but I'll go 8. Because, you know, sometimes some trees are going to grow a little bit bigger, but we get the idea there. So then for years, I'm going to go 0. We can go 1, 2, 3, 4, 5, 6. Yeah, I think we got enough space to double this out. So let's go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You always want to use as much of the graph as possible. And then for heights, we'll do something similar. 1, 2, 3, 4, 5. Well, I can't fit the whole thing in there, can I? But I'll go ahead and do that, and we'll just have 10 go off. Oh, you know what? I don't need to start at 0. So I can start here at 2, 3, 4, 5, 6, 7, 8. There we go. All right, so we said it was 0, 2, and then 2, 4. I'm sorry, oops, I didn't plot those points. I got to fill in my table of values here. So when I plug in 2 into my equation, I get 3. Plug in 4, I'll get 4. 6, I'll get 5. 8, I'll get 6. And if I plug in 9, I will get 6.5. So 0, 2, 2, 3, 4, 4, 6, 5, 8, 6. Oh, and I haven't labeled either. Years, tree height, feet, and then 9 we said was 6.5 and 10 was 7. And once again, we get a nice straight line for the tree height. All right, so thank you on the review. If you have any questions or I explain something differently than your teacher, please come to class with a question before you take the test. Thank you.